Clean architecture or vertical slices architecture, which one should you choose for your application? In this video, I'm going to compare these two architectural approaches, discuss what problems they solve, and see if we can figure out which one is better. From what I've seen in the .NET community, these two architectural approaches, clean architecture and vertical slice architecture, are probably the most popular choices, with clean architecture probably being the most popular choice by far. However, there's also a large part of the community that despises clean architecture and is very much in favor of vertical slices. Now, I know what you're probably wondering, which one of these two approaches is the better one? Obviously, clean architecture is the only correct answer and it's better than vertical slices, right? Well, not so fast. Actually, vertical slice architecture is better than clean architecture. Maybe we're looking at this from a wrong perspective. Discussing if clean architecture or vertical slices is the better approach is not a good use of our time, and I'm going to explain why that is the case. So I'm going to argue that neither one of these two approaches is the better choice per se, and I also believe that these two approaches are not mutually exclusive. You can have vertical slices while also following clean architecture principles. So let's first see what problem these two approaches are trying to solve. Clean architecture is all about controlling coupling. Here's the typical representation where we have the domain at the core of the system, followed by the so-called application layer that contains the application's use cases, where we implement our business logic or behavior and we orchestrate the domain entities. And then on the outer edges of the architecture, we have the presentation layer, which could contain API endpoints or maybe message consumers that are going to trigger our use cases. And then we have some infrastructure concerns such as our database, any external services, message brokers, storage systems, and so on. So the core idea of clean architecture is this dependency rule, which states that the outer layers are allowed to reference the inner layers, while the inner layers cannot depend on the outer layers. In other words, the dependencies are pointing inwards, represented by these arrows here. So what problem does this solve, and what are the benefits of this approach? Well, we are trying to control coupling. We want our domain, which sits at the core and contains our entities and important enterprise rules, to be independent of the other parts of the system. To achieve this, we simply don't let it reference any other parts of the system. But we do need to actually implement some behavior, which is where our use cases come in the application layer. And following the dependency rule, the application layer is allowed to reference the domain layer because it depends on it, but the application layer also needs to sometimes perform some operations that need to touch some external services such as the database and storage systems and message brokers, and it also needs a way to be exposed to the outside world, which is where endpoints come in and, for example, message consumers. So some of these details aren't that important for the use case itself, which is why we create abstractions to represent the resources or the operations that we want to execute, and this allows us to implement our use cases so that they are independent of these concerns that are on the outside edges of the system. And finally, the outer layers implement these concerns. So what we gain with this is that we control the coupling inside of our system, but we don't eliminate the coupling. The coupling is still there, we're just making it explicit. And another important benefit that this introduces is that it makes the core of our system stable. Let's look at the domain again, for example. Because it has no references to the other components or layers in our system, anything around it can change, and this should not have an impact on the behavior of our domain. The same goes for the application layer. If the domain layer changes, this can have a direct impact on our application layer because it depends on it. However, because the application layer does not or should not depend on the presentation or the infrastructure layers, then so long as we respect the contracts that the application layer defines, anything around it can change and the application layer should remain stable. The disadvantage of this is that it can introduce a lot of indirection because we're going to have a lot of abstractions typically represented as interfaces in C# and then the respective implementations as classes in the outer layers. One more remark I want to make is that you don't necessarily need to have have 4 layers like in this diagram. You can have more of them or fewer of them. The only thing that is important is respecting the dependency rule. Now let's talk about vertical slices. With vertical slice architecture, the main driver behind how we organize our system is cohesion. And cohesion means how related are certain components inside of our system. So the more related they are, the closer we want to place them together inside of our architecture. A very common representation for this is one feature or one use case. Like you can see in the example here, I have features for creating a product in the system, searching through the products in the system, or archiving a specific product. All of these are use cases, and you can imagine that they're going to contain a couple of components that are required to implement the functionality for this use case. Let's say creating a product in the system that could require instantiating a domain entity, creating a service class or a request handler that's going to store this domain entity inside of our database, and then we want to probably expose this through some sort of API endpoint that we're going to make available through HTTP. Now, another example is searching through the products in the system. This use case might need to interact with some search service, let's say Elasticsearch, or perform a full text search operation on a database in order to retrieve the results that the client is looking for. And these two features have different requirements, so we want to have a degree of freedom in how we implement them. But nonetheless, the main driver behind how we design our system is cohesion and the relatedness of the components for that one feature or use case. So the next question I have is, can you have both? What I mean by this is, can we combine the benefits of clean architecture with the benefits of vertical slices and somehow get the best of both worlds? This wouldn't be a pure clean architecture approach, and it also wouldn't be pure vertical slices, but I think there's a lesson to be learned from both of these approaches. So let's see what this could look like in practice. I'm going to start from a clean architecture implementation that's actually a sliced clean architecture, if I can call it that. I also like to call it pragmatic clean architecture because it makes more sense than what the common recommendation for implementing clean architecture looks like. So nonetheless, I have a domain project or assembly that contains my entities, but what I'm doing here is grouping them in some sort of cohesive fashion. So in the users folder, we might have a user class, which represents our entity, and then a domain event that describes what is some behavior that we could trigger inside of our domain. Then there is the to-dos folder that's going to contain a domain entity also, but we could also place some sort of priority enum. This could also be a value object, and we could have more classes inside. And what I'm getting at is organizing these types so that they belong to a cohesive whole and grouping them as such inside of the domain layer. Now, if we go into the application layer, you'll see a similar structure. We have the to-dos and users folder. However, the folders that you're going to see nested inside represent use cases or features. And this is why I was calling it a sliced clean architecture, because in the application layer, I'm organizing all of my use cases around features and I'm grouping them within a cohesive feature slice. So in the users feature folder, I have use cases like get by email, get by ID, login, register, and then in the folder for a specific use case, I might have classes that are required to implement this use case. Because I'm employing CQRS, I have a register user command, a respective command handler, a validator is also placed here, and a handler for the domain event. Within the handler, I'm depending on abstractions for interacting with any external systems. So this is what I meant when I said the inner layers define abstractions and the outer layers implement them. And then all of the logic required to implement a use case is contained within the use case itself. There's still a degree of indirection here because our implementations live in another project. However, the use case itself is relatively cohesive, and everything that's required for this use case is inside of one folder inside of our solution. And you're going to see the same approach applied in the remaining use cases that I have here. Then we have on the outer edges of our system, the infrastructure and the web API, which take care of external concerns such as exposing my use cases through API endpoints, which are again grouped into feature folders, or we could have been using controllers. The idea is still the same. We're maintaining these cohesive slices through our clean architecture. Within the infrastructure layer, we implement any external concerns, and the most notable one here is probably interacting with our database. Now, what would it take to transform this implementation that I have here into a vertical slice architecture? Well, let me show you an example, and I'm going to start by creating a solution folder. I'm going to call this folder sliced, and inside of it, I'm going to create another project, which is going to be an ASP.NET Core Web API, and I'm going to call it Web API Sliced. Let me create this project, and what I want to do here is merge all of the projects that I have for my clean architecture into one project for my vertical slices. So I'm going to close down these files, and then I'm going to do a bit of copy pasting. So let's copy everything that I have in the Web API project, and I'm going to paste it into my vertical slices implementation. This is what my program file looks like. It has a bunch of compile errors, and I'm going to solve most of these by referencing the respective NuGet packages. So I'm going to copy what the Web API was referencing, and I'm going to paste it here. And because I'm using central package management, this is just going to work. Now, this only solves part of the problem. We are still missing the types that were defined in the separate layers within our clean architecture implementation. So I'm going to solve this by creating folders for the respective layers, and then we can simplify this later on. So I'm going to copy what I had in the domain layer and move it into the domain folder. I'll do the same for the application layer. I'll just copy everything and move it into the application folder. So let me create this folder and paste in the files. And finally, in the infrastructure folder, which I already have here, I'm going to drop in anything that I had inside of my infrastructure layer. So the one thing that I'm missing is the add presentation call here. I'm going to add the dependency injection file. And then for the shared kernel, I'm not going to copy that. I'm just going to reference this assembly directly. So now the only thing that I'm missing is any NuGet packages from these layers. So I'm going to go ahead and add these because they are currently missing. And after I have everything in place, I should be able to build my sliced application. So let's see if it's going to build now. And you can see that the build succeeds. So what I did here is just merge all of the layers that we have as part of clean architecture into one solution. So we somewhat simplified our architecture. However, we still have a layered organization. So to make this a flatter structure, I'm going to introduce a features folder. And let's say I create a to-dos folder to group any features related to to-dos. And finally, let's define one complete feature. And it's just coincidental that this feature is called complete. Now, what I'd have to do next is take the respective use case or the files for it, which I had here, and move them into my feature folder. I might adjust namespaces as I go. Now this takes care of the use case itself. Now another component is also our API endpoint, which I have here. Then I'm also going to move into the use case. So now our one feature or one vertical slice contains the API endpoint, the respective command, the respective handler, and the validator for this command. So this is pretty much everything you might need to define a complete feature. We could replace the endpoint with a message consumer. Let's say we're picking off messages from a queue, and then we delegate the handling of this message to our use case. But you can see that I didn't really have to do a lot of work to move from my slice clean architecture approach into something that we could call a vertical slices architecture. Now, obviously, I would need to adjust more of my use cases to move into a completely feature-oriented structure, but I think you get the idea of how we could get there. Now, when it comes to communicating between our vertical slices, we could use an event-driven approach. And let's say we publish domain events like I'm doing here, raising a domain event, and then it's going to be dispatched when I call save changes async from my database context. This could trigger something in another vertical slice, and this is how we could implement communication between them. And if we need to share any behavior between our vertical slices, then we could either move that behavior into the domain and make it part of our entities, and then our slices can use this behavior, or we could move it into some service that we could make available to both of the slices, and then they can share whatever this logic is that we want to make available to multiple slices. Let me know in the comments if I should take my clean architecture template and turn it into a proper vertical slice architecture implementation. In the meantime, you can grab the clean architecture template from the pinned comment that's going to be right below this video, and you can do this exercise yourself. If you want to improve your software architecture skills, I recommend that you check out my courses with the main main one being the modular monolith architecture, and you're going to see how we can apply vertical slices on the system level. Thanks a lot for watching this video. Make sure to smash the like button, and until next time, stay awesome.